Well, good morning. Welcome to today's webinar brought to you by MACF and Florida Makes. I'm your host, Sherry Reeves, along with Christian Davison. We'd like to welcome you this morning, and I'd like to start off by saying I hope you, your families are safe and healthy, and your businesses are thriving during these unusual times. Today is June 30th, 2020, and we are starting at 10 a.m. Eastern Time. Today's topic, discover the power of Markforged 3D printing. I would like to introduce today's speaker, Joe Lajanusa, a little bit about Joe and Access Manufacturing. Joe graduated from California Southern, completed Rollins College Management Program. He has 30 plus years in sales management, and he also has 20 of those years in CAD/CAM sales with Access Manufacturing. Access Manufacturing Systems, Inc. is the largest CAMWorks reseller in the world. For more than 20 years, Access has delivered best-in-class manufacturing software and accessories, along with unsurpassed industry expertise to hundreds of Florida manufacturers and thousands of companies across the nation. Access Manufacturing Systems has been a proud member of MACF since 2006. A few housekeeping notes. As a participant, your audio will be in listen-only mode using your phone or computer, whichever is more convenient. Additionally, you will have the opportunity to ask your question using the question window. This is a live webinar event, which will be recorded. A link to the recording will be provided to you within a few days. Now, I'd like to turn the presentation over to Joe. Welcome, Joe.
Thank you. Thank you. I appreciate it, Sherry, and you did an awesome job on my last name.
I told you I'm trying.
So thank you all for attending this morning. We sincerely appreciate the opportunity to talk to you a little bit about something a little bit different than what we normally do here at Access Manufacturing Systems. As most of you know, we are a CAMWorks and SolidWorks reseller, but over the last year and a half, we have actually been providing 3D printers and additive manufacturing. So with that, I'll go ahead and get started and tell you a little bit about Access Manufacturing Systems and who we are. As Sherry alluded, we've been a member of the MACF for many, many years. We've got 30 plus years serving the manufacturing industry, providing various manufacturing solutions such as CAMWorks and Markforged 3D printers. We have offices located here in Florida, in Orlando, where our showroom and training facility is. We also have an office in Charlotte, North Carolina. Our corporate office is in Salem, New Hampshire, and we also have training facilities located in Illinois, and we also have one recently in the Atlanta, Georgia area. The real bread and butter of what we do is really our dedicated certified applications engineers providing training and technical support. That's really the lifeblood of any organization, and we have those on staff. So let's dive into the reason why you've all are attending. We provide a line of printers from a company called Markforged. Markforged has been around almost 7 years now, and they've really pioneered the strength of material with their printers. First line we're going to talk about is one called the Mark II. And just to kind of touch on the agenda a little bit, it's going to be a little bit of a mix of some PowerPoint. We're going to show you a video of our showroom where you'll get a chance to see all of the equipment that we have from Markforged. You'll also get a chance to see the printer in action, physically printing a part. And then at the end of that video, what brings it all together is our software. And I've got with me one of our senior applications engineers, Dennis Larscheid, is going to run you through the Eiger software and how you can take a CAD model and bring it to life in the printer, which is a really, really nice way to really tie everything together. So back to the Markforged Mark II. This is our desktop model. It's known for its high strength printing reinforcing your parts with composite fiber while actually 3D printing them. And it achieves unparalleled strength, stiffness, and durability in its printed parts. And it does that by the range of materials that the Mark II can print. It prints what's called onyx, which is a nylon and chopped carbon fiber infused material. So it's reinforced with a chopped carbon fiber. But the Mark II takes it a step further, because you also can use the strands of carbon fiber for reinforcement, as well as reinforced fiberglass and also reinforced Kevlar. So this really makes a desktop printer practically industrial grade for your use inside your shop or your office. And the print size, if you notice, is 12.6 by 5.2 by 6 inches. So it's a nice size to do some parts on a desktop printer. And this is a good example of something that can come off of that print size. Next, we have what's called our top-of-the-line industrial printer. This is the Markforged X7. This is the printer that I'm actually going to show you in a few minutes, the video of actually printing the part. So with the Markforged X7, you're going to get 50% faster print and 20% cheaper from the parts that you're making. It's directly able to replace machined aluminum with parts that are off of this industrial printer. The parts are printed with onyx as well as the reinforced carbon fiber filament. It also prints the fiberglass and the Kevlar. They're work capable and ready for the same day to use. It's kind of like the Mark II, but at a larger scale with a larger print size, as you can see. And it's also a faster print capability in turbo mode, which it also has the capability of doing. Plus, this also can outperform, in some cases, aluminum when it comes to a small variety of parts. It's got the continuous carbon fiber, stands up to some of the toughest applications. And I also, in that video, you'll get a chance to see real-world parts as well. It can be stronger than 6061 aluminum in most cases, and also about 40% lighter. These parts are perfect for manufacturing equipment, soft jaws, tooling, and also end-use parts right off of the printer, and you're able to use them. And then this is a good example here of a part that was printed, not this entire assembly, but for instance, some of the mechanisms that I'm pointing at, like here, for robotic gripping, being able to go down and pick in place. Those are really nice features of a machine like this, especially if you're looking for putting a printer through its paces. And that's what the X7 is designed for. It's designed for heavy-duty type production work. And if you notice, the print size is larger than the Mark II. It's 13 by 10 by 6 by 7.9. And you'll get a chance to see that when I show you later in the video. Finally, the other system that we're going to talk about, which is real exciting, this is metal printing. And there's so many people out there that when they come to a trade show and we talk about metal or we do these webinars, they kind of scratch their head and say, come on, can you really print metal? Well, the answer is absolutely. And we'll get a chance to show you the system as well. But if you take a look at the Metal X system, it is a complete system. So it's not just a printer. It's a printer that has the metal powder. It's bound in plastic, printed in a layer at a time to the shape of your specific part. And when you see that Eiger demo, you're really going to see how the whole thing comes together. The parts are scaled up to compensate for whatever shrinkage may happen during the sintering process. So it's actually printing the part, and then we take it to a wash. So now it becomes a green part. It's placed into the wash, and then the wash uses a debinding fluid to dissolve most of the plastic binding material in the ceramic that is used. So that way it is clean and it's ready to go right into the sintering oven, which is the Markforged furnace. So that's where the chamber is heated. its material specific profile, burns away any remaining binder, solidifies the metal powder, and in about 22 to 26 hours, you have yourself finished parts, and not just one part. When I show you the machine of the system, you're going to actually see just how large that sintering oven is. And the one I'm showing you is actually a small. There's actually a Sinter 2 that's available that you can print even larger. But this is a real good example of some impeller blades that you would machine on 5-axis CNCs, where you actually can print these, and they come out solid metal, right around 99% of what you're used to. So very, very strong end-use parts. And some of the applications that you would use for metal printing would be repair work, tooling, service work, end-use parts, and also replacement parts and prototypes. You know, keep in mind, when you think about 3D printing, we're not looking to replace the CNC machine. We're looking to complement the CNC applications with the various printers, whether it be metal or whether it be the composite. The goal is to put a printer in place to make prototypes, some end-use parts, to be able to do some fixturing and tooling, CMM, work holding. So that way you can use your CNC for what it's intended to be, and that's full-on production. Getting back to the Metal X, the print size is 11.8 by 8.6 by 7 inches. So let's briefly talk about some of the materials, and then you'll get a chance to actually see them when I go to the video. That's the cool part. So we've got the various videos. So the Onyx, like I mentioned, is a nylon mixed with chopped carbon fiber. So this is right out of the box a game changer, because it's going to allow you to create very strong parts with some heat resistance. It's got really nice surface finish, and one of the parts I'll show you in the video, actually you get a good opportunity to determine the type of finish that you need. And this material also comes in a fire retardant as well. So right out of the box, whether it be one of the lower end printers or even the higher end, you're able to use the chopped carbon fiber and nylon mix to create a very strong part. Next, we've got high strength and high temperature fiberglass. So this is also available in some of our printers as well. So that way you're able to deliver high impact resistance, heat deflection temperatures in a continuous fiber environment. And then the regular fiberglass, extremely inexpensive. It's 11 times stiffer than your traditional ABS printer material. Perfect for entry-level fiber for 3D printing. So if you don't want to step up to one of the larger or higher priced printers, you have the entry-level capabilities of still being able to make a strong part for what your need might be. Then, of course, our stiffest and strongest fiber is the carbon fiber. We have customers that do custom bike manufacturing, and they actually have the Mark II to be able to use the strong carbon fiber filament to be able to make the handlebar area a much strong support. When folks stand up when they're pedaling and they're able to put their weight on that handlebar, we're actually using this type of material for that. So it's our stiffest and strongest fiber to produce a high strength to weight ratio. Then we've got Kevlar. A lot of folks are familiar with Kevlar, with the vests and Kevlar jackets and things. Tough, lightweight material. It can also bend further than any other fiber, so it makes it ideal for 3D printing. If you need some tough, some stiffness, but also some bend capability, Kevlar is a great tool for that. And then in regards to our Metal X system, we actually print in Inconel 625, H13 tool steel, D2 tool steel, A2 tool steel, 17.4 stainless, and just recently copper. So we're excited about that, especially in the metal world when you're able to print these various metals. And in the development stage, we've currently got 316 and also titanium that are being developed. Yes, I said titanium. So that is real exciting for us. And then lastly, as far as PowerPoint is concerned, this is what my applications engineer, Dennis, is going to be walking you through, is the Eiger software. This is really what brings the printed parts to life. You know, it's one thing when you go to a trade show, you're going to see in the video, you're going to see the actual parts already completed, and that's kind of a wow factor, but how did they get there? And this is really kind of the icing on the cake, is being able to literally see your CAD file as an STL file come to life in the Eiger software, and then it's actually out to production and printing. So that's a little bit about the Markforged line from Mark II to the X7, and now I'm to the Metal X. Now I'm actually going to get out of the PowerPoint, and I'm going to run you through the video of our showroom so you can see exactly the machines and what they look like. So let me go to the video. Okay, so this is our showroom. This is the Metal X printer. So as you can see, we do have a little part in there. But this is where, in this area right here, this is where the actual filament is housed. And it's actually, in this case, it was printing 17-4 stainless. Once it's done in this process, it's then, and in some cases, the printing can be very quick. The printing part of it is not long at all. So once we take it off of the printer, we now put it in what I talked about earlier, is the wash bath. So this is where it's actually using the debinding fluid, and it's cleaning the part up, if you will. You open up these doors and you can put several parts in there to get ready for the sintering of it. And this is the sinter one, and it's a large piece of equipment, so you can fit multiple parts in there at the same time, depending upon the material. The next step up from that is the sinter 2. So now you can fit even more parts to be able to get done all at the same time. So this is the Metal X system itself. And what we also did up top here is that's just to show the exhaust for when you set it up in your maintenance or your manufacturing facility for everything to be able to go out of the shop. So I'm going to hit play. We're now, that's the Metal X system right there. These parts here are green parts that actually came out of the printer. So those would be ready to go into the bath and into the oven. Next, this is the X7. So this is the step up from the desktop series. This is the top of the line industrial series. This printer does virtually everything that you would need it to do minus metal. It's got laser leveling of this bed, so there's no need to manually have to do any type of leveling of the bed. It also has turbo mode, so if you've got production runs that need to get done much faster than a traditional print, you can also do that as well with this printer. And it is a workhorse. It is a high production industrial printer. This is where the filament is. So when you open this up, there's a dry box inside to keep the material nice and dry. So everything is self-contained. This actually comes off where my pointer is. This comes off, so it makes it somewhat portable, and you can actually move it from area to area that you need. So I'm now going to hit play, and we're going to actually see the printer in actually a potential customer that's extremely interested in the printer, and they want to get a chance to see their sample. So you can see by the size of the bed, we actually can put multiple parts laid out to be printed. So it's running through its paces, and then as you see, that is the extrusion head where the filament is coming out. Below that are the two filament containers. One of them could be the reinforced, and the other one could be the actual normal onyx chopped carbon. So you have the ability of being able to reinforce simultaneously while you're printing. And then as I run the video, this is the display here. So you can actually pause the job, you can reload your material, you can stop the job, you can track the time, how long it's going to take for this job to continue. And with pausing, I'll show you a part where you actually can pause the job. You can put a dowel in, or you can put some type of a small bolt if needed, recontinue the print, and it'll print around it, solidifying the process. So I'm going to continue that. We're going to see it printing some more. So if you've never actually seen a printer in action, this is actually right in our showroom. So you can actually come out at any point and take a look. Next thing I'm going to do is I'm going to show some of the sample parts. So this is a robotic gripper. So these are actually from a customer of ours. Dixon Valve and Coupling uses the Markforged equipment for actually gripping parts. They could also be used for gripping in a fixturing capacity, or work holding, I should say. And it's saving the time from having to use this on a CNC machine, where the CNC is used for making money and it's actually conducting the production operation, whereas this printer is actually being used to create the fixturing and tooling and things of that nature. So it's a great complement to the CNC, and you can actually get these parts in hours as opposed to sometimes weeks if you're ordering this type of special fixturing or tooling. Next, I'm going to take you over and show you the brake levers that were printed. And as you can see, as I mentioned earlier, you can see the various parts that were actually inserted into the brake lever. So these were inserted during the process. You hit pause, you insert it, you hit reload, hit play, and it's going to run you through the actual part. And this is a good example of the reinforced carbon fiber, the fiberglass, the Kevlar, all of the various parts. This is the resolution test that I talked about earlier. So you actually can print a sample and you can see the layer height, and you can determine how much resolution, how fine of a part you actually need. And you can do that with the resolution test. This is the one that if you're in the machining world, you're really going to love. These are the soft jaws that we were talking about. If you were to come to our showroom here in Orlando and literally pick that up and feel how, first of all, feel how light it is, but also feel how strong it is. I mean, this part is reinforced carbon fiber, and it is completely ready to go in the machining capacity. Very, very strong part. I've dropped it several times, and it's never had any issues at all. Luckily, it didn't hit my toe. This next part is a very, very interesting part. It's one of my favorites. This is actually a space clamp, and it's a replica of what was made to go up into the International Space Station. So this part right here, this white, is the actual flexibility of the nylon with the stiffness of the carbon fiber. So if you need a part that has some type of clamping capability, this is an ideal application for it. Then we'll run through some of the other samples. We talked about metal. Well, here is a great example of a 17-4 stainless part that came right off of the Metal X. So it was printed, it was washed, it was sintered, and it comes out as a full ready-to-go part. This top right here actually comes off, and then you can take this plate and you can bolt it to whatever the operation is that you need. What's really impressive, take a close look at this. This is what really impresses me about metal printing, and that's this ball joint. This ball joint, if you take a look, it printed the thread. So there was no secondary operation needed as far as taking this off and putting it on any other type of equipment to create the threads. This actually clamps right on and threads in, and the holes, everything about this part was 3D printed, so it was ready to go the minute it came out of the sintering oven. Next to it is a good example of the composite version, a larger version of this, also threaded. So right off the printer, it's ready to go and used. Really nice example of the difference with that. But the threads were absolutely right printed in. And then here's a good example. This is that part that I talked about earlier for the metal. This is the composite version. And these are some other good examples of some parts. If you notice, again, here's the threading right off the printer. And then here is a good example of a prototype for a working gear. So the parts are right out of the printer and ready to go into end use or prototype. And then lastly, I wanted to end it on a note with our industrial grade desktop printer. This is the Mark II. This is the one that I talked about to start the presentation. And as you can see, you can also have the various reinforced filament and the normal onyx filament. It's a smaller print size, but it has all the same capabilities in terms of the display, so you can actually go in and you can pause the job, restart the job. Very, very nice workhorse for entry level into 3D printing. And then I didn't show this, but behind it is the dry box. And that's where the filament is to ensure that the material stays nice and dry when it comes out and there isn't any moisture in it as well. So it's a real nice entry level type to get into the 3D printing. And then this is just a final look at the showroom that we have here in Orlando, and we'd love for you guys to come down and take a look. So that is it for my end of the presentation. What I'd like to do is now turn it over to my applications engineer, Dennis Larscheid, and he's going to take about 15 minutes or so and run through the Eiger software, and then we'll get a chance to have any questions that you guys may have. Take it away, Dennis.
All right. Thank you very much, Joe. Nicely done. What I'm going to show you is Eiger and some of the functionality that it has. It's a great slicing software. Cloud-based. For another cost, you can go the other standalone version, but what I'm going to show you is the cloud-based version. When I go into Eiger, it is much more than just a slicer. It's going to be a full file storage. So you can see we've got all of our Access employees have their own folders and everything's separated that way. You can go into their folders and clone a part if you needed to. And it's also a printer manager. So if I go in to see my printers, I can see which printers are turned on, if they're ready or not. If I click on a printer, I can see how much onyx is loaded, what fiber is loaded, how much of that is left over. So it's going to keep track of all of that. Nice thing about the X7 is you can also take photos. You have a webcam and a screen capture that you can do with the X7 too. So it's not just a slicer, but what I'm going to do is show you, I've got a part that I've opened up in a CAD system and I've saved it as an STL, and I'm just going to bring it in from scratch. So my first job is just to click on Import STL. It's going to let me browse to it. And then I can put it in whatever folder I want to put it into. I'm going to put it into my folder, and it's going to open up that part. So now I've got work to do. I've got to decide how I want to set this thing up on my printer. What is going to be my best way to get the best quality print? I'm going to worry about things like supports and strength and stiffness. So the neat thing about Eiger is I just select on a face and it puts it normal too right down on the flat of the table. So I'm just deciding which way I think is going to be the best way to get the stiffness I want, the finish, just the fit and function. So something like this, I may want to just go ahead and, I could print it up this way. You can also come over and manually rotate that just by changing over to the manual rotate. And you're just clicking on any one of these lines and manually rotating that. All right, so I've decided I'm going to print it like this. If I look over to the right, I can see we've got 3 basic categories for functions or for options that you have in Eiger. Over on the left-hand side is going to give me my part details. So once I get put reinforcement in here. So we're going to do some carbon fiber also. And you can also tell it what type of layering the reinforcement is going to be. So I can go ahead and hit save, and now it's doing the slicing for me. You can navigate away from this page while it's doing it, but it's a pretty quick slicer. So I've got on my left-hand side, print time, material cost, and whatnot. And now I can go in and say I want to do an internal view. This is how you control your layers of the fiber. So if we look at this in the purple, that's my supports. In the blue, that is my fiberglass. Now I can go and control that even further. I can just come here and drag my layers over, and you can see how quickly that comes in and builds that up. You can add multiple layers inside the part. It's a very strong slicing software, and it is pretty quick. I can do a 2D view. This will let me run through every single layer of this, and I'm seeing my infill, I'm seeing my fiber, my supports. You can see just how Markforged has done a really nice job with this. And if I like what I see, I can go ahead and save that. Go back to my part mode. My details for the part have been updated. And I can start printing now. So the neat thing about Eiger is I can print right from here. If I'm at home, my printers are ready. Doesn't matter, I can go ahead and print. What I'm going to do is hit print. And now it's going to show it to me on the print bed. If I want to do multiple parts, I can do that right here at this time. If I want to move this on the printer anywhere, I can. But if I were going to print this, I would just hit print. And we are done. So it's very quick and easy with Eiger. They've done a really nice job with their software.
I think one of the nice things about the software, Dennis, is the fact that over to the left, it gives you the details. You know, $3.85 for that part cost, 2 hours and 21 minutes, and you know you've got a part.
Right, and then you can just go in and start making changes if you want. You know, I can go right back to my part mode, start making changes to make it faster or cost less or better finish. It's just all done here before you're sending it out to the printer.
Excellent. Very good. Thank you, Dennis.
You're welcome.
So just to kind of wrap up before Sherry takes over, I want to take this time to thank everyone for having a look at the Markforged equipment. As I mentioned, our showroom is right in Orlando, not far from the downtown area. If you're not able to come here, we can certainly do a web session for you to run you through the Eiger software and maybe even one of your parts. So we'd be more than happy to give you an idea of what it would look like printed. Thank you again for your time this morning, and I'll turn it over to Sherry to see if we have any questions.
Thank you, Joe. Christian, do we have questions?
Not at this time. If you have any questions and you're an attendee, your microphone is muted, please use the chat function or the question function in your sidebar to send any questions you may have to Joe and Dennis.
Well, Joe and Dennis, I guess you were so thorough, we don't have any questions. Is that correct, Christian?
No questions.
Okay. Well, once again, we'd like to thank Joe and Dennis for their time today and their many years of experience in the manufacturing arena. We'd also like to once again thank Florida Makes for their continued support of Florida manufacturers, and we thank you for your participation in today's webinar. If you would like more information about MACF, please visit our website at www.macf.biz. For future events, please visit our website events page, and any upcoming webinars that you would like to see from experts, please contact Christian and myself so we may provide these free webinars to you as members. As you exit the webinar, we are seeking your feedback on how to improve these webinars and better meet the needs with topics of value. Please watch for upcoming webinars through the MACF and Florida Makes websites. I bid you a good day, stay well, keep manufacturing, and have a great July 4th. Thank you so much.